Innovation. Hi, welcome. My name is Jeff Crandall. I lead the additive manufacturing group here at Connecticut Center for Advanced Technology. I'd like to welcome you today to Unlocking Innovation with 3D printing of industrial grade thermoset elastomers with our guest chromatic 3D materials. We're going to walk through a very, very quick introduction to CCAT, and then we'll begin the main presentation. So just a reminder that today's event is being recorded. If you have any questions during the event, please type them in the chat section. So you'll see a icon to hit chat. Go ahead and type it in, and we'll either stop the presentation then and try to answer your question, or we'll wait till the Q&A session at the end. And then after the event, you will receive a survey. So we ask that you fill it out in order to help us understand how to make this better. A little quick intro to CCAT. So we are a applied demonstration technology and training center. Our mission is to really look at how a technology is applied and validate it. We do demonstration projects for companies, and then we assist with the onboarding of that technology. So the whole concept is to help build the supply chain, the industrial base, and then provide upskilling, up-training, and for the individuals at the company in order to give them the skills they need in order to implement this technology. When we look at CCAT as a whole, we have, when we're physically in our Advanced Technology Center, our ATC is divided into 3 primary laboratories. We have a composite center, which is a joint public-private endeavor with Pratt & Whitney Aircraft and Goodwin University, the state of Connecticut, as well as CCAT. We have a digital transformation lab that is focused on, in Industry 4.0 technologies. We do a lot of work with metrology, contact and non-contact inspection. We do a lot of work with structured light scanning and other metrology technologies. And then we have our additive lab, which once again, I have the pleasure of running. We're involved with a lot of different types of additive technologies. And once again, when we look at the work that we do, it's to work with companies, with manufacturers, to help them understand it, how to apply it. We can help transfer that technology to them and provide the skills upgrading for their staff. We have, in particular, a technology adoption program, which is funded through the state of Connecticut. And once again, this is part of that activity where we're doing introductory workshops for companies to help them understand what the full scope of technologies are that they have available. If they're interested in exploring the technology, we can do demonstration projects for them. We have grant funding available to help pay for the onboarding of the technology. We provide support all the way through, and once again, up to and including training. So with that, I'm going to go ahead and turn it over to Bob Geffert, and he'll introduce the team from Chromatic. Chromatic, to me, is an incredibly interesting company. A lot of their focus has been on developing the materials for this process. And so they have some very unique materials, and this is a relatively new additive process, and they're leading the way in many different ways with it. So I will go ahead and turn it over to you, Bob.
Great. Thank you, Jeff.
You're welcome.
And, thank you everyone else for joining today. Just would really like to thank Jeff Crandall and the team at the Connecticut Center for Advanced Technology and this opportunity to share chromatic 3D materials and our technology with all of you today. When you look at chromatic 3D, what we've done is we've commercialized a true full solution that enables companies to implement 3D printing tech into their products. And we consider this to be really groundbreaking printing technology and capabilities. And the key is that we're offering a durable, robust elastomer urethanes that previously were available only through expensive or a time-consuming molding or casting process. So one of the things to take away from today is that these are real-world materials. These are elastomer urethanes that are out in the world now, from 50 Shore A to 90 Shore A. We also have a Shore D 65 material. And what we've been able to do is, with these stronger materials and really having this printing technology in the market now, we've been growing our footprint of companies globally to utilize not only the materials from a high performance standpoint, but also our technology, which encompasses software, materials, development contracts, and actually parts production as well. So we actually started back in 2016, and we were led by Dr. Cora Liebig, who Cora has over 25 years in the materials industry. And what we found was that there was a real need in the industry to enable companies to take real world materials and put them into geometries without the supply chain challenges, without the lead time challenges, and obviously without the cost of tooling. And what we've been able to do over the number of years is take these materials and actually turn them into a printable product. So what we have is a true full solution. And Cora has been leading our company since 2016 when we started. You'll also be hearing today from some of my colleagues. You'll be hearing from John Schober, who's our VP of Business Development, and then Jeff Tronis, who's our VP of Operations within Chromatic. So you'll be able to get some different flavors from the technical side to the opportunity side as we work through. Think about urethane elastomers, right? They're everywhere. And typically they've been out in the marketplace in lower volumes or very, very harsh environments where durability is key, mechanical performance is key. Materials that are going to perform minus 20 C to 120 C. That's the actual space that we are working in. And that's encompassing everything from industrial parts to transportation to aerospace and defense. We're working with these global manufacturers all over the world and in a lot of different sectors. So, right now we're working on some automotive opportunities in aerospace, defense, but also in the consumer side as well. And what we're starting to see is, more and more people seeing the value of being able to create this. And what we'll do is we'll jump into the technology so that you can actually have a better understanding of what this process actually looks like. So Jeff Tronis will be walking us through the technology side here. So Jeff, why don't you go ahead?
Yep, thank you. So as Bob mentioned, we've got polyurethane materials. We have an A side and a B side. They're typically mixed near a 1-to-1 ratio. They get pumped from reservoirs and metered into a tip that you see here, this white tip in the image here. This is the first time they come in contact. As soon as they start mixing in the static mixer, they start reacting. The reacting material is extruded out the tip. This is a live sort of real-time printing of a part that you're seeing here. And what you'll see is a partially, as it's coming out the tip, it's obviously partially cured, but you see a new layer of gel getting put on a previous layer of gel, and those can still bond across those layers because they're not fully cured. This setup this two-component setup allows us to print at relatively high speeds and these high durability materials. We also have the ability, though, to expand out into multi-material or gradients within the part. If I set up the system with the 4K setup, I can have two A sides, two B sides. I can, if I have a Shore A70 and a Shore A90 set up on the printer, I can change on the fly from a 70 to a 90 and back again, all in the same print with adhesion, with high adhesion. I can also change from, if I needed to go to an 85, I could mix the 70 and 90 and get kind of an 85 for a while and switch back, vice versa. It gives us the ability and some flexibility there to produce unique geometries and performances throughout a part that it's difficult to achieve other ways. The material also is very good with textiles, printing on metals, printing on plastics as far as the adhesion and combining of parts and like soft touch on a fixture or adding a seal to a metal component or, you know, some of these applications will get talked about later in the presentation. So I'll get past those. And as Bob mentioned, these legitimately are like production grade materials in that when you think about additive, you know, in a layer by layer additive situation, you don't typically see the Z axis being comparable in strength as X and Y. So you see very high strength in the Z axis. You can see, as you can see here, there's very smooth surfaces without post-processing. That can be very, and we can achieve overhangs. We don't typically use support materials to achieve this. It's printed at room temperature. It's printed, it can be printed in an open environment. It doesn't need venting, that kind of thing. And I just really need an XYZ motion machine to put this on. If you have a gantry for me, if you have a robot arm for me, you know, we've got a material we can start printing. And as you can see here, we've got a robust material, putting it through kind of its paces and demonstrating its capability. And here, I mean, we talk about multiple applications for our material. We've got kind of a CV style boot that qualified at 100,000 kilometers as printed on a vehicle test platform. We're working in the aviation space and looking at flame resistance and of our materials, automotive applications, and we're printing very robust, reliable parts. We got a little video for you, so I don't have to talk.
You see the video?
Yeah, it's playing. Yeah, it's playing. So I'll describe it a little bit. This is, what you'll see here is that the thin layer that you can see through, that's really one layer thick. And then there's a bead on the inside and outside of that to make the seal. And that was that quick. And one of the benefits of this material and being the reactive material is that you do get a very dense, very strong part. So on the left here, you'll see a CT scan of our material post printing, and comparing it to an FFF or FDM style print that certainly is not dense. And so you do see the strength and the sealing benefits and things like that with the reactive material. I think John's going to take over and talk about applications.
Yeah, so the images that you see here are reflective of the range of the geometries that we can print. You see here on the left bellows, which shows the multi-material printing, and you see certainly the green and the black, and those are different materials. The way we had printed this one, it was more rigid towards the edges and softer towards the middle. The green is the softer materials. We actually printed that without any supports. So we do have the ability to print overhangs. That's not an unlimited ability, as with any other 3D printing technology. But different constructions that we have, we are able to print without supports. The bladders are something that we had produced over the last year or so. Saw an opportunity within the industrial bladders market to demonstrate that you can print a full bladder that can expand and contract. We don't have the video here, but we had created a video previously about that. And the way the bladders are traditionally produced is they're molded, two pieces are molded, and then they're adhered together somehow. There is some real life benefits towards printing of a single piece bladder, and it's not just in the fact that you don't have those seams where the two different molded parts come together. It's also the fact that you could put different materials in different locations to address, to give you greater flexibility in certain areas and greater durability in others. Next image is seals and gaskets. So we do like seals and gaskets as an application where there's lots of different geometries that we can produce parts. And we like round things rather than sharp things, just the way that our printer works. And the image that you see on the right is kind of an extension of our strategy in seals and gaskets, in that you can produce billets from which seals and gaskets can be machined. It's actually a big part of our business strategy right now, is to offer a product line focused on near net shapes, and the seal market is one of those, but there are other applications out there where you basically can print your near net shape and then machine other parts into that. Tooling would be another application where that would make sense. So all the images that I just shared with you, all the geometries that I just shared with you, were kind of standalone parts. These images are intended to show that we can print, especially with our urethanes, we can print onto other materials and get very strong adhesion. So in the case of fabrics, you can eliminate seams and eliminate the need for adhesives. And you also see some pretty interesting patterns that you can print onto those fabrics. We have the ability to print onto metals, and also incorporate electronics. So you can provide some kind of encapsulation or sealing of an electronic part, or if you're printing a part and you want to embed electronics into it, we have that ability as well. It's much easier to do with 3D printing than it is with other elastomeric manufacturing processes. Next slide, please. So let's go a little bit into our offering. So we're in the business of getting printers and materials in the hands of our customers. We have a printer with software and materials, so kind of a full solution for our customers to take on. We're not in the business of providing parts to customers on an ongoing basis. It's just not how we're going to grow as a company. But we do look to sell our materials and our printers to organizations like prototype houses, design houses, and certainly OEMs, contract manufacturers, what have you. So again, our approach is get materials and printers in the hands of our customers. We have developed our own materials. We call them the three names you see here: ChromaFlow, ChromaLast, and ChromaMotive material families. These are very similar to the kinds of urethanes that you would find on the market. They're not space age materials that nobody would ever know of. It's just that we've figured out the chemistry to allow them to be printable. So we've given them different names here, but again, they're very similar to the urethanes that you would find on the market. And so people come to our website, they come talk to us, and they look at our materials and say, hey, will these fit to what we need? And sometimes they do, quite often they do, but sometimes they don't. We also have the ability to work with our customers and make their resins printable. So tailoring to specific material properties, specific colors, other additives and powders that you might include. We have that ability to work with our customers to make their materials printable. Also wanted to highlight that we are working on EPDM. Everything we focus on this far has been with urethanes. That's the first material that we went to market with. We're currently working on EPDM, and we have others that this technology is also going to be applicable for. Two of the more prominent ones are SBR and FKM. We heard a lot of feedback from the market on all three of those materials that, boy, you could solve a lot of problems if you could 3D print these materials, and so we have those in our pipeline. Next slide, please. So let's talk about our printer. We like to tell our customers or people interested in our technology that our printer is very easily integrated into your plant and into your lab. The footprint for it overall is not very large. And then the print size that you would find in that printer is basically roughly a 2 foot by 3 foot print area in the X and Y, and then 8 inches that you could print in the Z direction. There are more limitations in the Z direction than there are in the XY. We could make a much bigger, wider printer. In fact, we can work with our customers to make a more custom printer to address some of their needs. A little bit more difficult to expand in the Z direction, but we've also been working on making that happen. But with our standard printer that you would find information on our website, fairly small footprint, and it gives you the ability to print a range of different geometries and part sizes. And you'd be able to, again, plug it in. There's no heating, no ventilation, no humidity requirements that you have. I mean, you do need some humidity control. And the only other thing that you need other than just being able to plug it into your wall is an air compressor. But again, happy to work with folks on developing custom printers. Okay, so I'll jump into use cases here, and I'm going to start with the first one and hand off to Bob for the other ones. I know there's some interest from folks in aerospace applications, and we have been working with NIAR out of Wichita State University, who has been working with CART, a consortium of aerospace suppliers. And they have been evaluating our technology for a variety of aerospace part applications. And one of the tests that they had run was the burn test that you see here. I know there was a question coming into this webinar about whether or not we've done testing for under the aerospace materials standards. This is one of them. We have not done all of them, or I would say even a comprehensive set of them, but this is one of them. And there was a lot of excitement around these results because there is strong interest from what we've heard in the aerospace market towards being able to print interior parts in relatively small volumes, say for replacement parts. And they've struggled with finding 3D printing technologies that can pass this test. And that goes back to what Jeff had talked about previously, that if you have those layer lines, you have some porosity in those 3D printed parts, you struggle a little bit with passing these tests. But because ours is as durable and robust as it is, and you don't get the kind of porosity that you get with other 3D printed parts, and there is that continuity in the Z direction, we get some very good test results here. So we were excited about these opportunities and certainly see the opportunity to work in the aerospace industry on these interior parts. Okay, I'm going to hand it back off to Bob here.
Great, thanks, John. So some of the things that you've seen already really showcases from a process standpoint. You know, we're working with customizable properties, multi-material designs, large formats, complex shapes, and really comes down to strength and durability for that broad set of product applications. We've done a lot of work on the seals and gasket side, and you'll see here that we're working with companies that will be familiar to you and industries that should be familiar to you as well, from automotive to rail to medical devices. You'll get an idea as far as some of these geometries. This example was with Daimler Chrysler. Oftentimes we will have people approach us with geometries that are elastomers that have not been produced in years to decades. We had an opportunity for a geometry that was from 1945. So think about that long tail business or those low volume replacement parts that are out there. This technology tends to be a great fit for that as well. And in this case with Daimler, it was a 50-year-old grommet that they couldn't source that was going to shut down production. And having worked in automotive before, understanding the cost liability of having a line shut down is it can be incredibly expensive. So in 2 days, we were able to take this grommet, this 50-year-old grommet, meet their material standards, and print 5,000 of them and have them delivered, to support the remainder of their need for 2022. And this is part of the service and the support that we provide to our customers when they do bring in the technology. We're there to support from a technical service standpoint, to help them get those geometries printable and coach them through the process as well. And here's a kind of an exploded view of how those parts were being printed. You'll notice that mixing tip that's here, we're printing with those parts. We're working with a liquid material. We have a suite where we have the software that's controlling not only the speed of the extrusion, the speed of the XYZ of the printer, and then also, dependent on the chemical reaction of those materials as they're curing. So, these are parts that are realistically they're curable very quickly. They're curing as they're coming out of that mix tip. And then to get final properties from a post-processing standpoint, really the only thing that we recommend is going into a thermal oven at 100 C for 8 to 10 to 24 hours, depending on your geometry. John had mentioned before, it's a very small EH&S footprint with this. We're printing at room temperature. There's not ventilation that's required. We're not washing parts with IPA. And these parts and materials, they don't have the porosity that you'll see with other processes. To give you an idea, one of the areas that early on in the presentation, Jeff had shared that membrane part. So that's an area that we've been focused on from the seals and gasket market. You can see a part that I'm holding up here. This is something that took really minutes to print, and it's incredibly durable. So that's an area that we're focused on. And the only way that you get into these markets is by passing that series of tests and expectations that the materials will perform. Obviously, it ends up being application specific in a lot of cases. And what we've been doing is a lot of testing on our own, and then also externally to make sure that our materials are passing some of these requirements. John shared some before, what we were doing with Nair. Here's an example of, how our material, our Shore A material in the 55 to 60 range is performing against heat transfer oil, gasoline, ASTM oil too. And that's the temperature in hours that the material's been exposed to. One of the areas that we've had great success with and has been published is working with OBB, so Austrian Rail OBB. There's a real need in the rail market for replacement parts, and these are typically parts that are not done at high volume, but they are critical to their overall, to the overall characteristics of the train. So things like buffers, anti-vibration, bellows, membranes, and seals are key. This grommet that you see here is really exciting because it's something that it's printable, and it's a cable protection where they can cut this grommet, in that area, wrap it around the cable, and then glue it together. And that's saving, hours and hours just on the maintenance side of things on the train side. And then, kind of to finish up, John had talked about, and Jeff as well, printing on other materials. Because of the nature of our technology and the materials, it bonds extremely well to metals, plastics, wood, glass, other plastics. If there's any level of porosity to the mating material, it bonds extremely well. That's the beauty of the liquid state and the chemical reaction that we're working with. What you see here is actually a tractor pad. So this was for a John Deere tractor where we printed with our material. This solid black area is what we had printed directly onto that part. And then what you'll see is that those pads actually on that tractor. Now, what you saw before was that printed onto aluminum. That was more, so that we could take it to shows and not have to carry around a 60-pound weight. But you'll see here, it's printed actually to steel, and I'll kind of give you an idea of how that process has worked. So I think this was at the Minnesota State Fair. There's a level of durability here with these materials that, we're excited to demonstrate, because for the time that I've been on the additive space, I've not seen materials that have that level of durability. And then the other characteristic of our properties are, these materials are also machinable. So we don't utilize plasticizers in our products. So we have the ability to machine those parts as well. If there are any questions, we're happy to support and answer. The key thing to think about with this technology is that it's going to allow you the opportunity to adapt and make your designs much more quickly with our material. It's an elastomer innovation solution, if you will, and you can scale this from the R&D side to the innovation side all the way into production. And you're working with the same material properties from point A to point B. You're not having to work with an ABS-like material or a urethane-like material. These are true urethanes. These are elastomers. And then we also have that roadmap that John had shared, where we're working towards existing right now EPDM. And to give you an idea from a durability standpoint, printed onto fabric, I've taken vice grips to this. The material will actually tear itself before it'll tear that structure underneath. So anywhere that you're printing directly onto things is an application opportunity and area.
So, hi, Bob and team. There is a question in the chat that I just want to put out to you guys. So I have a question from Aaron. He works at a nonprofit called Forge, and he helps connect startups to suppliers. He would like to know if there are any Connecticut-based companies that have your equipment. He's really interested in the overmolding capabilities, and he feels that this would be in high demand with the startups he represents.
Sure. Yeah, great question. So we currently do not have a service bureau with our technology in Connecticut. What we are able to do is we are producing parts for companies at this point. We have our facility in Golden Valley, Minnesota, and then we also have a facility in Germany as well, where we're printing parts for people. And in some cases, those are proof of concept parts, but also into volume production. So we're happy to support and would love to connect after this.
And I'll add to that. We are. I mean, that's part of our strategy right now is to find manufacturers in different regions of the country who will take on our technology and can serve and support organizations like the ones that Aaron is referring to. So, as you guys are walking away from this session, happy to have those conversations if you know of anybody in that area that could have an interest in working with us and taking on our printers.
Yeah, something else that we didn't tackle within the presentation that I think it's important to share is that this technology, we're dispensing at low pressure, and what that allows you to do is have the opportunity to dispense that into a mold or into a casting at low pressure, where you don't have to put it into an injection molding machine, or you're not having the expense of, from a tooling standpoint, you could even 3D print some of your own tooling. That's one of the areas that we're also very engaged with. We call it our additive assist manufacturing. That's part of that, innovation solution that we have, and we're working with companies right now within that, and we have the ability to generate those molds and or cast and to print onto them for people initially before they bring the tech in.
Okay. One of the questions that's also been asked is, what are we talking about price wise for this to get started in the technology?
Great question. So the printer that the two sizes that we have, the largest one, which is about just over 2 feet by 3 feet in the XY, almost a foot in the Z, you're looking at about $40,000, $41,000. And then what we do is we provide technical service on top of that, which is basically it's an hourly rate that you would purchase in packages of 5, 10, and 20-hour packages. And we build that on an annual basis for people that are looking for more support with the G code or geometry creation.
Okay.
And we also include within that material as part of that service, that technical service. So 2.4 kilograms of material per month, as well as 100 mix tips per month within that.
Okay. Could you review very quickly what the available materials are and what your material development roadmap looks like and what it looks like timing wise to bring on new materials?
Sure. So right now, from a material standpoint, we're working with Shore A materials, 50, 60, 70, 90 in Shore A. And then we have a Shore D 65 right now. All those technical data sheets are available on our website. We can also share those to folks here. And then we are working right now on EPDM. We're actually having successful prints with EPDM right now. And that's something that we've been working on pretty closely. But for the most part, we've been focused on the elastomer urethane market within that range.
Yeah, I'll add a little bit to that. So regarding the EPDM, we are looking at being able to demonstrate that at some trade shows later this year. So maybe at the IEC trade show and certainly at Formnext, as that's what we're targeting. So from a timing standpoint, after that, we expect to be able to start engaging with customers. And then more specifically to the urethane products, the different material families that we talked about. Bob had said that we were able to offer a range of hardnesses. The different variations that we have in those 3 different material families are based on other properties other than hardness. So one of the stronger ones there was our Chromolast. We're focusing on low compression set. That's for many of those sealing applications where low compression set is a requirement. One of the other material families is better for flowing into fabric and adhering to fabric. And then the other one is kind of our workhorse, that it's general if you just need a part where the requirements aren't too difficult on the other mechanical properties. And I forget which one is. So you got Chromolast, Chromamotive, and Chromaflow. The Chromaflow is kind of the workhorse for us. The Chromamotive is the one that's a little bit more appropriate to integrating into fabrics. And then again, Chromolast is more for those sealing applications where you need lower compression set.
Okay. And what I don't know if it's material dependent. What is a typical build rate? I know it's a very fast process compared to many of the additive processes, but have you, do you have statistics on what the build rate is?
Very geometry dependent, but I'd say 0.5 gram to 5 grams a minute is kind of normal. We can certainly exceed that by a fair amount on large parts or very dense, very solid parts.
Okay. And are there any limitations on part size potentially using this technology?
So more on the small end than the large end, I would say, because it's a gel and because of the size of the tip we're using. It's difficult to achieve very high resolution or very small feature size. We can use a smaller tip. Smaller tip means shorter life on the tip, more replacements more often needed. But bigger is, I would say bigger is, I don't want to just say bigger is better as a broad statement, but bigger is easier than smaller. Limitations wise, some of the benefit of our material in reacting to itself could go away if you got a part size that was large enough. So I would say there's some design considerations there, but we can also increase our print speed as far as our flow rates and our XY traverse speeds. We can change those. Then we start to kind of hit limits. It's minutes, not seconds, that we would need to talk about there. But
Okay.
It's hard to bound that exactly without looking at the geometries. But we can get pretty large parts. I mean, we just got done printing a part that was 18 inches tall with a 14-inch diameter flange on it. 14, another one that was 12 inches tall. I mean, we can get some pretty decent sized parts.
Very good. All right. Are there any more questions from the audience? All right, seeing none. Do you guys have any closing remarks or anything that you'd like to add?
Realistically, just like to thank everyone for attending and the opportunity with the Connecticut Center for Advanced Technology. We're a pretty open organization in that we're happy to have additional conversations come out of this and work on specific projects with people. And also, when you think about materials, customizable colors, customizable contents, if you needed something specific to a certain like FR, we can work with people to get that development as well. We have these off the shelf resins right now, but we're not limited to that from a growth and development standpoint.
All right. Very good. Well, I'd like to thank you very much for your presentation and just, it's amazing technology, and your capabilities are great, and so I'm hoping that this spurs a lot of further conversation from the folks that are watching this. So with that, I think what I'm going to do is go ahead. We'll finish up your formal presentation. I'm going to take just another couple minutes to talk about some programs that we have here at CCAT. So if anyone wants to hang on we'll go through that very quickly. And once again, thank you all very much for being here today. All right, so once again, we do a lot of work with small to mid-sized manufacturers. And as I mentioned earlier, the program that we do that with primarily in the state of Connecticut is our Additive Technology Adoption Program. We're here to support small to mid-sized manufacturers. So Aaron from Forge was talking about interfacing with startups. And so certainly, having interaction and having conversations and with that group of people would be very interesting for us. We've, here again, can do projects for people. We can help them select the appropriate additive tools. Once again, training opportunities. We're going to talk more about our funding assistance and our resources we have for that in project support. One of the cool parts of the Additive Technology Program is our Additive Quick Start program. So we understand that a lot of companies that aren't into additive manufacturing or aren't into these new technologies yet are concerned about the risk associated with onboarding the equipment. And so the Quick Start program allows us to take printers, train your staff, bring the printer to you, let you use it for 6 weeks to print whatever you would like to on it, and then, you know, pick it up at the end of 6 weeks. So it's a great opportunity to de-risk exploring these other technologies. We have traditional polymer, Markforged polymer printers, composite printers available, and we're just introducing the Formlabs resin printers as well. So once again, we can help you understand how those technologies work, and you'll have an opportunity to try them out on yourself before you know, deciding whether or not it makes sense for your business. If it does, we have a variety of programs available for grants. In particular, for the additive program, we have the additive adoption program, which allows for matching grants up to $20,000. So once again, whatever you're interested in from a printer perspective, if it's less than that, you know, you can apply. I think the minimum project is 5,000. Up to 20,000, and so that money is available for you to use when you need it in the future if you don't use it all to start with. That's available on a first come basis. And then we have a variety of other grant programs for technology onboarding, as well as workforce development and training. So we encourage you to go to our website and check that out, or to reach out and give us a call, and we can talk more about that. A lot of interaction that we have with people starts with booking a consultation. So once again, you can go to our website, tell us a little bit about yourself and what you're looking for, and then we can reach out and either set up a Teams call, or we can have you come here. We can go to your place and you know, really take a look at how these technologies can apply to you and help with your understanding. We have tours that we open up to the public to come in and take a look at what we do here. So our next tour is on Wednesday, April 17th. And then another part of our facility is our digital training labs, and we have open houses there that are happening on Mondays during the month of April and May, on Monday morning and Monday afternoon. So here again, you can go to our website, get more information on joining one of the tours for the Digital Thread Lab. And with that, I'd just like to thank everyone once again for attending. Please fill out the questionnaire when you get it at the end. And thank you very much.